Hi, I'm Stuart and welcome to Sirennet Television. Back in September, I had the opportunity to go over to the Whelen Engineering facilities in New Hampshire and in Connecticut for an unbridled view of their manufacturing facility, the laboratories, as well as a whole range of space within the respective factories. It was a fantastic trip, and I really would like to first of all say many, many thanks to everybody at Whelen Engineering, both in New Hampshire and Connecticut, that went out of their way to help me with respect to this particular film that you're about to see. We're going to go through different sections of the factory, and you'll have a chance to see how Whelen puts together their product that you use. Let's take a look at this particular unit here. Now, what I want to explain to you, if I may, is the made in America and manufactured in America. Now, with made in America, basically it goes like this. 20% of the content of the product in question would qualify for made in America. But when you manufacture in the United States, you have to be over 85%. And one of the things that I learned when I was at the Whelen facility, they're not at 85%, they're at 98%. I'm not joking. Whelen makes screws. They make virtually every single Terry component that goes into this siren amplifier that I'm holding in my hand here. Now, when I say virtually everything, they obviously don't make the rubber that goes over the wire, and they don't actually make the copper wire, but they buy the wire and they buy the rubber component that goes over it inside the United States. So from a manufacturing perspective, Whelen is undoubtedly a unique company. And we will have that opportunity to check it out.
We're on the road, as you can see, and heading towards Chester. Because in Chester, we have the second Whelen facility, which we're going to get a chance to film today.
Hey, Stuart.
Hey, how's it going?
Pretty good.
Yeah.
Today I'm going to be looking at this particular part right here. The vendors requested a change in fillets to the areas, so I need to import a new circuit board into this assembly. So what I'll be doing is going through the features of this part to modify it to make the vendor's request. Then as I go back to the assembly, I need to match up my circuit board to that assembly and make sure that everything is going to fit fine with his requests.
So basically you'll generate these drawings and then send them out to, what are you saying?
We generate the drawings, we generate the 3D file, then we send that to our tool shop and they actually make the tool for the product. Once we're happy with the tool design and the tool, if it's a die cast part, we don't do die casting, we'll actually send that tool to the die caster.
Right, and they'll actually put it together then.
Yeah, they'll make the changes I request, but the original design came from this for the tooling. And we can also, relax the part so we can show it folded and flattened. And then we provide that to our sheet metal fabrication facility, and then they can do the flat pattern layout of that so they can know where to make all their cuts, where the bends occur, and then, we can again show it in form state.
That we're working on right now.
And this is exactly how the PC board, you're laying out essentially how the PC board will look before it goes to the board manufacturer.
That's correct.
Yeah.
That's correct.
And you're putting obviously all the different components on the board with respect to how it'll be positioned for the tracking.
That's true. That's very true. Yep.
So basically, okay, so this is the actual component now that has come out from the 3D printer.
Yep.
And that then in turn goes into this machine over here.
They're two separate machines, it just was a view of the power
Sure.
for you. So basically what it does is it prints a 5,000th layer, scrapes it off, puts down glue, puts another 5,000th layer, glue, another 5,000th layer, so it keeps building this part up. So you can imagine the part just being built layer by layer, 5,000ths. ABS. I already played with it.
So this, for example, here, came out of that machine we just
Yes,
looked at.
that was when we first made the ion houses.
Right.
So it allows us to make physical parts and just put them together. This is a life test room.
So basically in here, we're testing the longevity of every single Terry item
We'll do, basically we test, see how long LEDs last, how long circuit lasts. Some of the steps have been on the test for 10 years.
10 years. So some of these have been running for 10 years constantly?
Okay. This is an integrating sphere.
Right.
It's used to, or we use it to measure the color and the light output of the light source. We can measure it in infrared or in the visible spectrum.
And what type of product is in here right now? What do we have in there?
That's just one of our circuit boards. I'm not even sure it's a circuit board from one of our, they're LEDs.
You're measuring they just said a moment ago, you're measuring the blue is what you're going on?
Yeah, here's the data for it. So on this graph here, you're looking at the intensity or the power versus the actual wavelengths, and the wavelengths are covered in the visible spectrum on this graph right here. And then this chart here will show you whether or not it's compliant to any of the SAE colors. These boxes right here, and it shows that it's in the box.
Not directionally, so since it reflects everywhere, you gather every single bit of energy. That's kind of cool.
All right, this is one of our photometric chambers. We have a light set up in here right now. It's one of our light heads. This is a goniometer, and
It's a what?
goniometer.
Okay, so what does that do?
It's a positioner, and the light is mounted. There's a X and a Y axis, and the center of the light source spins about those axes. And the detector is 100 feet away through those baffles. So we're measuring the light intensity versus angle.
Standard, it's environmental control, humidity, temperature, all the environmental controls in each one of these. There's a standard we have to meet.
So in other words, this room is certified with respect to the testing that's going on here. And there's very strict rules on the certification.
Very strict.
So this is what we're seeing here on the computer screen of what we've just been looking at inside.
Yeah, and it's toggling back and forth. This graph right there, the line graph, that's going to come back. Right there is the intensity versus the angle. And then this graph is similar to an oscilloscope. It's measuring the light intensity versus time. So you're actually seeing the wave of the flash.
So Rick, what's it doing in here?
They're measuring an aviation beacon to meet the FAA certification levels. And we use this shorter tunnel because we have to get more sensitive measurements. When I told you down to 1 candela, 2 candela, which is a little harder to measure in the 100-foot tunnel. This is just our second 100-foot tunnel.
So we're down in the underneath section here at Whelen, and we're going into the other test area. Now this is where they do environmental testing. There's a whole range of equipment in here. We'll take a quick look at some of these right now. So Rick, this area here is really critically important to selling emergency warning product because people use radios, and those radios are very susceptible to interference.
Right, so there's two things we check for. Our product radiating any emissions, or if their product can stop our stuff from working. That's called susceptibility.
Right.
So where you bombard it with power.
Right.
This is our RF EMC lab. It's a CISPR 25 lab. It's certified to that standard. We can do all kinds of RF testing and anything you could think of.
And it's all behind this door.
Yep.
And
These are amplifiers and controls. Those are examples of antennas for different frequencies. We can run from, I'll basically say 10K to 18 gigahertz.
So here we are inside the RF chamber, and inside this area here, I just showed you a moment ago that your cell phone won't work, because this is the area where they will test to make sure that no radio interference is going to come from any product that Whelen sells. And they extensively test repeatedly. So again, let's check it out. We're now inside Whelen's sound chamber, and it is pretty darn big. As you can see behind me here, there's an area where they're working on some speakers. These are the outdoor warning speakers. And as the rest of the gang come through there, we can kind of see people moving around. But basically inside here, this is where they will do sound testing to verify the actual output of the respective siren driver. So again, this room is pretty darn interesting. So basically down here, this is the light bar production area at Chester. And this is where you make runs less than 50, because obviously up at the New Hampshire plant, you make runs over 50.
You're right. justice bars.
So again, all the justice bars being put together here for a particular client, and then obviously out the door they go after that. Program here what you need, and then it pulls it down from the rack.
Yeah, you just scan a part, and it goes in our system, and we'll bring up whatever we have in stock of it. We just hit it, it'll bring it to the best location. It tells us how many quantities there are, different bins. Very organized. All right. Yep.
So this line is all new,
This one's a little older, this one just got replaced.
brand new. So this is the repair department in customer service. So over here is where you test in the real life as far as installation and components go?
Yep, and development. It helps us develop all the fits because everything's custom fit now to every custom year.
Right.
So this is a beautiful facility for that.
Old Saybrook, yes. And this is the Cantrol system test vehicle. This is the photographic area here at Whelen, where they actually will take the individual photographs for the particular product in question that will go on their website or in their catalog. It's pretty much cavernous inside here. Well, here we are at the Whelen's New Hampshire facility. It's one of two facilities that Whelen has, and we've been given the opportunity here at Sirennet to have unbridled, and I said unbridled, which means we can go virtually anywhere. Actually, it means we can go anywhere. Yes, we're going to go anywhere inside this building and videotape the manufacturing that takes place here at Whelen's New Hampshire facility. I'm pretty excited about it. John Olson, who's the president of Whelen, has very kindly agreed to take me on this unprecedented tour. So sit back, enjoy. There's going to be lots of manufacturing in it, so there's not going to be too many lights, I'm afraid. There will be some, but not too many. But most of it will give you the opportunity to see how this facility and all the great workers inside it put the Whelen product together. So let's go inside and check it out right now.
These actually are for the Vertex. Right. Right now we're using the UV cure material. We're changing it up a little bit. It's going to come through here. We're using these PVA machines now with like a 3-axis type, like a box, and it's like a. We have one in here. Yeah. It fills in. It fills the back. And, right. It's actually the same stuff we use in the PTWs. The other robot will come along.
It's brand new. We've only had this a few months. It's the only one. There's only 2 of them in the country. We got.
What does this machine do, John?
This is a laser, but it's using fiber optics. It's not running right now, but it's a different system. This is a fiber optics. It does heavier plates. And very laser cutter here. Down, draws it down so you get more thread.
having done over here, John?
Same thing, done there.
Okay.
Yeah, we have duplicates of every machine in the place. In case one goes down for maintenance, we keep going. See, the lasers I showed you at first will not do tapping and punching.
Right.
So that's just flat sheet cut. This is where we have to punch holes, tap holes, and then cut them out. So it does 3 operations. Here is a creation of my engineers. They mounted a robot between a lathe and a milling center. And it takes material, comes into the lathe, does its thing, cuts it off, the robot puts it in the milling center, it does its thing, and it's all done. And it goes out the conveyor, and we can use it right away. And that runs all weekend with nobody here. When it opens up, and this does all of the light bars, bases.
Punch all the holes in it.
Cut the holes. That way we don't have to keep resetting. You can walk in there. Start down on that end where they take reels of pink. I don't know exactly how many, but they're gradually showing up more and more. There's a lot of things that are no longer, you just can't do things like this.
Do you make your own PC boards?
Yes. Right over there. A stack of PC boards on. It goes through this machine here, and it silk screens, so to speak, if you want, prints on the solder location. Okay? Puts the solder paste on.
Right.
Very thin. Okay? Then it goes down and it goes into the insertion machine. This has already been pasted on those silver blocks. Okay? Then it goes down here. And this machine is picking up, called a pick and place machine. It picks the part off the reel, okay, and puts it in the right box. All programmed. We can do up to, well, you can see how many reels we can put on. I think we can do 40 in each one, so we can put a lot of different parts on before we have to run the board through a second time.
Okay.
And that's the component parts there.
The diode or the resistor or whatever.
That's right. Yep. Yep. The only thing this machine doesn't do is what we call power parts, because they're the big parts, the big wires. So those are hand inserted or inserted in Connecticut on an automatic insertion machine. Okay. Pass. If it rejects it, it prints a ticket that goes with it and says what's wrong with it. Yeah, go ahead.
See a little bit better?
That's spraying a coating.
Just to protect the coating.
Protect the coating.
It's the glue machine.
Yeah. Then it goes through an RF oven and out. Huh? Yeah. RF, radio. Yeah. You can see the coating from this angle.
Right. Just goes in with baked in.
Yeah. No, just to identify the coil. There's multiple, in this one here, there's 4 or 5 different coils in there. One is line coil, one is power coil, one is control
Take it out. Thank you.
Here's the tiniest one we make, and here's the biggest one we make. We're also, those are toroidal transformers, and I'm not sure that anybody else in this country makes it. So we have a toroid winder. Moves up and down, and it burns whatever shape you want. Yeah, this exact shape in, which would be difficult to do if you were trying to do a...
So this is a tool making a... This
is carbon.
Yeah.
Okay,
But this
here.
is actually the tool, right?
This is the inside shape of a single pioneer. Okay? So they burn that down in because you can't reach down in and do all of these. So you rough them a little bit, then you sit in there and 24, 36 hours later, it's burned out. Okay? And you cut the stuff out of carbon. This is one that uses the brass wire, miles, hundreds and thousands of miles of little fine brass wire, and it cuts like a saw, but electronically. Best description I can give. We make our own die-cast mold here. All our own die-cast mold.
This is the grinding shop. So in here they do the few thousandths of an inch worth of work as far as making sure the tools are incredibly accurate.
Checked out, repaired, and then goes back with a green tag, goes back on the shelf. So a guy goes over, gets his order to run a certain tool he knows is ready to go. Right? Oh my God, I can't run it today, I gotta get it fixed. And when they take it out, they hold it up, like nothing wrong.
You'll recognize that too.
Yep, yep. That's a vapor type.
So basically, the concept of
No, this is water line. Barrel of material, 25 gallons of water. So every drop is recovered. It's rolling away to the bottom, recycled, and what we have here, Stuart, we'll walk around, but this is an automatic reflector line. There's 5 injection molding machines making parts. The robot takes the part out of the machine, trims it, whatever, drops it on a conveyor, comes down here, lines up properly.
In this particular area here is where Whelen keeps all of the respective dies to manufacture all of the different beacon dome assemblies that they need. It's absolutely vast.
Great one.
Now what's this press used for?
That makes shells and bucks and big parts.
This is a total of 700 tons. 17.
Actually, they call it a 2,000 ton machine.
2,000 ton machine.
Now, tonnage is the clamp force. Gone through this vacuum metallizing system, and this is what it looks like. Part.
you have it, a Sirennet film of the Whelen facilities, both in New Hampshire and in Connecticut in the United States. Now, of course, Whelen didn't start as the mega corporation it is today. It started as a very small family-run business. It's still family-run, by the way. But George Whelen and his wife Betty, in 1952, started a very small business out of a garage in Deep River, Connecticut, making aircraft warning lights. That's how they started. George, under some persuasion, decided to put that aircraft warning beacon into the police market. And as I say in the classics, the rest is history. So they moved from that small garage to a larger facility in the 70s, also in Deep River, Connecticut, and then ultimately to Chester, where the large plant is today. That also, by the way, includes an airport, because they have outdoor warning, they have aviation, and they have automotive. Of course, you also saw the footage of the New Hampshire facility as well, which they started back in the 80s. Now, George, alas, did not live to see all of this grow into what it is today, and his sons have taken diligent care, along with everybody who works at the company, to make sure Whelen is a proud name in the automotive warning industry. So I would like to thank many people at Whelen for letting me have a look around their factory. But before I go and do that, let me tell you a little bit about the size of the place. The Whelen facilities combined, that's the New Hampshire and the Connecticut facility, is 900,000 square feet between those two factories. They actually take up a total of 50 acres. So, with that having been said, I would like to thank Rick Morrow for very kindly showing me around the Chester facility. And again, Rick, many thanks for your time. You're a very busy man. And of course, John Olson, who's the president of Whelen, who took me on a tour of the New Hampshire facility. And to get John to do that, well, it's very special indeed. In fact, actually, John was like a kid in a toy shop. I mean, man, he just loves that place. So again, thanks, John, for that. Of course, a big shout out to Brian Zebedee and Kent Bruce, my two North Korean minders, who made sure I didn't go into too unrestricted spaces, although I did give a slip occasionally from time to time. Also Keith Nelson and Howard Burke as well at Whelen, who allowed me come and see the facility. Now there's many more other people who I'd like to thank, those who work in the facilities, those who work in the laboratories, and those who even make the tea. So again, many thanks to all of you. I'm Stuart, and thanks for watching Sirennet Television.